Hey team, welcome. I want to give you guys a tutorial video on everything you need to know about special right triangles. So let's start by talking about what makes these triangles special. What makes them special is the shape from which they come. So our first triangle comes from a square. If we draw a line right down the diagonal of this square, we create two right triangles. And we know that these angles, 90-degree angles split in half, creates 45-degree angles. And so this triangle is called a 45, 45, 90 triangle. It's our first special right triangle. Okay. Now we know from a square that the legs are the same. And so that holds true for a 45, 45, 90 triangle. The legs must be congruent. So that means if the bottom is x, then the right side is x. All right, now if we use the Pythagorean theorem, x squared plus x squared equals our hypotenuse squared, we would end up with our hypotenuse equals x times the square root of 2, which gives us our relationship here. The hypotenuse is radical 2 or square root 2 times bigger than the leg. So we have two relationships. The legs are the same, and the hypotenuse is the square root of 2 times bigger than the leg. All right, so let's look at a couple examples. In example 1, we know the legs are the same. It comes from a square. So if the right side is 8, then the other leg must be 8, which means the hypotenuse must be that same 8, but times by square root 2. All right, let's look at example 4. It's a little bit trickier because there's a radical for one of our legs, but that does not change our first relationship, which is the legs are the same. So if the first leg is radical 2, then the second leg is also radical 2, which brings us to our hypotenuse. We take our leg, which is square root 2, and we multiply by the same thing we did in the previous example. We multiply by the square root of 2, which gives us the square root of 4, and simplifying that gives us just 2. So our hypotenuse has a length of 2. All right. Let's take a look at our second special right triangle. This is special because it comes from an equilateral, a triangle that has all three equal sides, which means it also has all three equal angles. All three angles measure 60 degrees. And we form this special right triangle by cutting it in half. We've got an angle that is 90 degrees. That 60-degree angle at the top gets split to be 30, and our 60 degrees in the bottom left does not change. And so we call this a 30, 60, 90 triangle. All right, now in a 30, 60, 90 triangle, all three sides are different. We've got a short leg on the bottom. We've got a long leg here as the altitude. And then we have our hypotenuse. Right. Now, our short leg, if it's called x, let's just define it as x. Well, then we know that the hypotenuse is 2x. And that's because the short leg was cut in half. If the left side is x, then the right side would be x, and the whole length would be 2x. All right, using the Pythagorean theorem, we can figure that the long leg is the same as the short leg times radical 3. So there are two relationships you need to know. From the short leg to the hypotenuse, it is a times 2 relationship. Double it. The short leg to hypotenuse is double. The short leg to the long leg is times by the square root of 3. All right, so let's look at a couple examples. All right, first, when we approach these problems, we want to identify the pieces, right? The short leg, the long leg, and the hypotenuse. All right, so in this case, our short leg is the one that we know. It's 4. Well, short leg to hypotenuse is a double relationship. So a double that, it becomes 8. I know my hypotenuse is 8. And from the short leg to the long leg, I multiply my short leg times radical 3. All right, let's look at another example here. In this case, we know the hypotenuse. The hypotenuse is what's given. So if the hypotenuse is 18, I'm working backwards to find the short leg. In this case, I divide by 2, which gives me 9. And then for my long leg, I take my short leg and multiply by the square root of 3. All right, so in summary, we've got two special right triangles, 45, 45, 90s, and 30, 60, 90s. These pictures are extremely helpful as they define the relationships.